All right, we're on the last page. A man is pushing a baby stroller. Compared to the magnitude of the force exerted on the stroller by the man, the magnitude of the force exerted on the man by the stroller is, again, it's Newton's third, so it's the same force. So the answer is C. Whoops. Keep doing this. Next one. The magnitude of the force that a baseball bat exerts on a ball is 50 newtons. What's the magnitude of force that the ball... I hope you're getting the answers here. 50 newtons. Again, it's Newton's third law. Newton's third law. Aluminum block weighing 20 newtons. So that's, again, this is where you have to figure that this is the weight. This is Fg. If you have Fg, you can calculate the mass. The mass is just the weight divided by gravity. So 20 newtons divided by 9.8 meters per second squared will tell you the mass. In this case, the mass is, I need a calculator. I'll keep going while I'm calculating. It says, is sliding from left to right on a horizontal steel surface. It's acted upon by a 2.4 Newton friction force. So if I'm going to draw my picture here, it's going to the right. It's going to have a friction force to the left. The block will be brought to rest by the friction force in a distance of 10 meters. So D is equal to 10. Diagram, draw an arrow to identify the direction of each force acting on the block. So I already drew friction. It also has weight, which will be Fg. And if it has Fg and it's on a surface that can push back, you will have a normal force. So those are my forces. That's all you need. Some of you are going to think that there is, I'll just change colors here. Some of you are going to think that there's this force in this direction, F applied. There is no applied force. The reason why it's sliding is something already gave it a push. It continues to slide because it has inertia. And it will continue unless it's acted upon by an outside force. And in this case, the outside force is friction. So that's why it's going to be brought to rest eventually. All right, I'm going to stay in this color. Determine the magnitude of the acceleration of the block as it's brought to rest by friction. So our equation's F net equals ma. You look at your picture here, the only force that's acting on it that's not balanced, these two balance each other, is Ff. So that 2.4 Newton friction force is our net force. The mass I just figured out was 2.04. Should plug that in. So when I solve for A, 20 divided by 2.04 is, that's not right. It's not 20. It's 2.4 divided by 2.04 is equal to 1.176 or 1.2 meters per second squared. When you're doing this, I would have gotten 1 point off. When it says show all work, here's your equation. That's number one. Number two is your substitution with units. I did not put in kilograms there, so I would have lost a point there. And then your last thing is an answer with units. So A is equal to that. All right, compared to the inertia of a 0.1 kilogram steel ball, the inertia of a 0.2 kilogram styrofoam ball is inertia. Like I said before, is resistance to change in motion. Things at rest want to stay at rest. Things in motion want to stay in motion. That's Newton's first law. We measure it by measuring the mass. Doesn't matter what the material is. Styrofoam sure is less dense than steel, but you have 0.2 kilograms versus 0.1 kilograms. So the inertia of the styrofoam ball is twice as great. The answer is A. If the mass of a moving object could be doubled, the inertia of the object would be doubled. Like I said, inertia is mass. So that's C. A rocket in space can travel without engine power at a constant speed in the same direction. Constant speed in the same direction. That sounds a lot like the first law. The first law says an object in motion will stay in motion at a constant speed in the same direction unless acted upon by an outside force. The reason it does that is because it has inertia. That's that resistance to change in motion. Number 26, 20 kilogram mass moving at a speed of 3 meters per second is stopped. So stopped means V final is 0. How many seconds must the force act on the mass to stop it? So if I write this out, it's a FNet question. It says it's stopped by a 15 Newton force. It's a 20 kilogram mass. Basically, we have some of the velocity and we want to know the time. So we're just going to leave what's the change. Again, A is delta V over delta T. You can't forget stuff that you learned earlier. Delta V is going to be 3 meters per second down to 0 meters per second. So the delta V is going to be 3 meters per second. Technically it's negative, but they just said the magnitude of the force. This would have been a negative force there, divided by delta T. So I think it's 15 newtons equals 60 divided by T. So T is going to equal 4 seconds, if I did my math right. That's D. Constant unbalanced force of friction acts on a 15 kilogram mass moving along the horizontal surface at 10 meters per second. If the mass is brought to rest in 1.5 seconds, what is the magnitude of the force of friction? So again, this is kinematics combined with forces. You have a change in V of 10 meters per second. The delta T is 1.5 seconds. So I can find A from that. A is delta V over delta T. And I'm given the mass. So if I want to know what the force is, F net equals MA, I just plug in my numbers. So the mass, 15 kilograms, times 10 meters per second, that's my delta V, divided by 1.5 seconds, equals my F net. So 15 divided by 1.5 is 10. 10 times 10 is 100. So we don't even need a calculator for this. The answer is B. All right, last question. Block A is pulled with a constant velocity. That means A is 0, F net is 0. Get in the habit of doing this. Up an incline as shown in the diagram below. Which arrow best represents the direction of the force of friction? You don't even need this for this. If it's moving in this direction, friction will be in that direction. So I think B is the answer. All right, I hope this helped.